The Metropolitan Water District of Southern California takes taste and odor seriously.
You know, we put out water that satisfies every federal state requirement, but it's unpalatable. What have we accomplished?
When people taste them in their water, they have the perception that their water is unhealthy.
Which is the approach that Metropolitan takes, heading off taste and odor problems before they ever reach the treatment plant. The Reservoir Management team is involved with every aspect of source water supply, from storage to planning.
The idea is to design these structures to let you avoid the problems.
In 1999, the district completed a new 800,000 acre-foot reservoir, nearly doubling the storage capacity for Southern California.
It has wonderful characteristics from a limnological point of view. It's very deep, about 260 feet deep at the deepest end, steep sides. We expect it to be very good in terms of water quality problems.
The inlet-outlet tower has ports on 9 levels to facilitate selective filling and withdrawal. A secondary inlet providing nutrient-rich water was strategically placed to minimize taste and odor problems.
That water is being brought in very deep into the reservoir and in such a way that it will remain deep in the lake.
The potential trouble spot in the new facility is the forebay. At 15 feet deep, it receives abundant light and a constant flow of nutrient-rich water. This makes it a prime target for attached algae growth.
Because of the geology and the groundwater being so close to the surface, it couldn't be made deeper. So we will have to live with it.
For Metropolitan, live with it means careful monitoring and regular treatments.
Hopefully we can manage the problem through treatment.
But how to keep the problems manageable? The key is to catch events early while they are still easy to treat.
We can take the data and look at it and see hopefully where things are going and how things are changing over time.
Algae blooms grow exponentially, so early detection provides a window of opportunity for treatment options that may not be available later on. The only way to spot these trends is by studying recent and historical data.
We've actually increased our monitoring program in Lake Matthews because we've got some historical data now to point to a time that may be more problems for us than we have in the last, say, 3 or 4 years in that lake.
Data tracking is the cornerstone of the early detection program, but it doesn't present the whole picture. Metropolitan has problems with attached algae.
And the best way to identify and find those things is with divers, to actually go down and physically examine the bottom. It's almost impossible to do it from a boat.
Lake Matthews had a problem. The culprit was extremely low light adapted and grew between 30 and 80 feet deep.
It was almost found accidentally. One of the divers just did a deep dive and voila, there it was. And it literally was like a carpet. You could peel it up off the bottom.
Massive taste and odor producing algae mats. After using about 400 tons of copper sulfate on that lake alone, Metropolitan turned to the science of limnology to manage the problems. Rather than treat the entire lake, they divided it up into 7 sectors, which were monitored and treated individually. By treating a taste and odor event early in the growing season, before most other utilities would consider it a problem, Metropolitan has lowered their dependence on copper sulfate and successfully prevented the problem from coming back.
That's the tack that we're taking. We're not looking to see when we can treat, but more when we don't have to treat.
Is it everywhere? Or just
Only on this part. Once you start getting into the flow, then you start getting some of the other stuff.
Also in the flow, I think it's scrubbed.
The dive team can learn a lot from visual examination, but a complete analysis can't be done in the field. Algae samples collected by the divers are taken to the laboratory for microscopic examination and identification.
If we see things that we already know to be producers in that reservoir, then there's no need to do any more work on them.
If the usual suspects aren't found, there may be a new organism causing problems.
What sometimes happens is that we don't see what we have historically associated with TNO in that reservoir, in which case we look further and maybe do some isolating.
By identifying the culprit, treatment decisions can often be made based on past experience with the same organism.
When you run into unusual situations, then you have to be able to, one, identify what is unusual about it, and number two, what you should do about it.
Copper sulfate treatment is still used, but only sparingly.
And if we can catch the problem at an early enough point in its growth cycle, sometimes a little bit of copper sulfate will tweak the system enough so that some other organism comes in and replaces it.
The area being treated has also been reduced. The result? Increased diversity of benthic organisms and a decrease in the number of taste and odor events.
Our objective isn't to just kill everything in the lake, but to just modify.
Copper treatments can be effective, but Metropolitan prefers to operate around problems if possible. Some techniques, like blending or selective withdrawal, require little more than operational changes. If taste and odor levels become severe enough, some reservoirs can be taken offline.
Basically, the entire organization can become focused on these issues if they are significant enough.
Early detection and response can require a lot of resources, but the basic principles Metropolitan uses can be followed by any utility.
What my group tries to do is to solve the water quality problems in the reservoirs before they get to the treatment plants.